King applications set it to 15 minutes or so, but typically all other applications set it to like at least an hour, or in some cases even a day. Some applications like meta applications, they probably don't even set an expiry, or maybe have a very long expiry that lasts for months. That's not really recommended if you want to have a very secure application. Hey everyone, welcome to today's video. Let's find out if JWTs are actually safe, or if you're making some critical mistakes that are causing your applications to be vulnerable to threats. So JWTs are one of the most widely used authentication methods when it comes to authentication and authorization in web and mobile apps. JWT is a basic JSON based token. It's called JSON Web Tokens. It consists of three parts basically and contains information about your session, a signature and a header. So before we jump into understanding if your tokens are actually safe, let's find out what a JWT actually is. So let's dive into it. So JWT basically consists of three parts, like I said: a header, a payload, and a signature. A token looks like this. If you see, there are three parts separated by a period. The header consists of an algorithm and the type. The algorithm is what is actually used to generate this JWT. Then there's a payload. The payload could contain information about the user, the session, like the name, email address, etc. And finally, there's a signature block. The signature is the signature that is used to ensure that there is no one who can replicate the token, who can create a copy of your token and use it in an incorrect way, a way in which your application is not intended to be used. Basically, this is to protect your token so that it's only being used by the person who it is intended to use it, right? So basically, this will ensure that your token is only being used by the user who generated this token or who logged in into your application. So let's go to the JWT.io website and look at an example token. So if you see, like I said, three parts. This is the header, this is the payload, and finally this is the signature. So now, without actually changing the signature, if I try to modify the payload, you would see that it shows an error that this is an invalid signature. So basically, because of the signature, and the signature we'll get into how the signature is actually generated in a second. But if you, without changing the signature, if you try to update the data, for example, if you change this to something else, then the signature, so this is where you're generating the token. But if I try to change the data over here without the right signature, this is going to fail. So that's basically a very simple example of a JWT token. The token could contain a lot more information, and there could also be parameters like an expiry, etc. We'll get into all of that very soon. So let's see how a token is actually generated. So usually it's a client who tries to log in on a server or an application, and the server returns a JWT token after doing some processing. The server actually has a secret key. Now this key is basically the whole reason for security when it comes to your tokens. If you do not keep this key secure, if this is something that someone can easily guess, then your whole authentication system can be a total failure. The secret key is only available on the server, obviously, and this is something you need to keep very close to your heart. You can't let anyone have access to it. This has to be very, very private, because this is the key that is going to be the key for actually generating a very secure token. And now let's look at this. So a header and the payload together, combined with the key, will actually generate the signature of your token. Together it forms a JWT, a JSON Web Token, which has a header, a payload, and a signature. Now, to get into some basic examples of how your tokens could be insecure and how you can protect your tokens, we are going to look at a very simple application that I have built. So here, if you see, we have a very simple form. It has a username and a password and a login button. And then there are three functions over here, using which I'm going to make a call to an API, which I'll show you in a second. So we'll make three calls: one without actually using the authentication token, one with using an invalid token, and a call with using the valid token. So let's get into the server as well. So this is a server. It is a Node Express based server. It's very simple. It has a login API. It accepts a username and a password in the body. It checks if the user actually exists. If yes, then it generates a JWT. Now for generating the JWT, we are using this package called JSON Web Token, and I'll show you the function. And for the JWT, we are passing the payload as the ID, username, email, and saved payment. So we'll get into the data in a bit, and then we are just returning the payload. And we are returning the response with the token. Now there's another API that I've created. It's called test. This one basically just simply returns a message back to the user saying request received, and this is by the user. This is the username of the user who is making the request. Very simple, very straightforward. Now let's look at some of the data that we have. So we have a users file. So we don't actually have any real users, but we just have simulated this. So we have some usernames and passwords created in a file. Now these users would in an actual application, these users would come from the database, but right now they're just lying in a file over here. And we also have some saved payment details. For example, every user has their credit card information that is stored with us. This again will be coming from a database, but for now we are just using some mock data. Now let's see how the user is actually fetched. So we have a function get user and get user save payment details. We don't need to actually get into the implementation of it. This is just some logic that is being used to get the actual user from your database. In our case, it is the file. So using the correct username and password, we're going to get the user and log that user in. This is the main part of the application. This is where we are generating a token. So if you see, this is very simple. We are just using the jwt.sign method, which comes from this package called JSON Web Token. We pass the payload. The payload in this case is this object, which has an ID, a username, email, and saved payments. And it's setting an expiry for 1 day. Okay, I'm going to comment this out for now, and we'll see how these tokens are being generated. Lastly, I have an auth middleware, which we'll get into in a bit, but this is basically going to ensure that we validate the tokens that we're generating every time the user hits our server again after logging in. Now this server is already running on a port 4000 for me. In addition, you already saw this application, the front end app that we've created. Now here what we're doing, when we have a form, a very simple form, which has an input for username and one for password, and there's a login button here. Upon logging in, it's calling the API, it's passing the username and the password, and it's getting a token back in the response. This is what you saw over here. We are passing the token, the JWT, as a field called token in the response. And then we are setting it to local storage. And we are setting this state variable called as user logged in to true. And if that variable is set to true, then we would see 3 more buttons. So if you see over here, we would see 3 more buttons, which would help us to call these APIs in 3 different ways. So we are calling the API without token, we are passing an empty string, we are passing an invalid token, and then we are passing the actual token as well. I'm just going to fix the name of this function called test API. This is actually the same API being used, so I'm just going to fix that really quickly. Right. So every time we are making the API call, we are passing the token in the header of the request. We are passing a header called authorization. This is how usually JWTs are passed, and we just log in the response for now. And in case of errors, we're also logging the error, as you can see over here. Alright, really simple, nothing magical over here. Only other thing to note is if the user is already logged in, then I'm going to look at the local storage, find the token, and if that token exists, I'm going to set the user to logged in. Okay, cool. So now let's look at the application. Let's actually try some things out. So if you can see, we are already looking at the 3 buttons over here. This is because I already have a token in my local storage. So if you open the inspect tab, if you click here and if you go to application, you would see local storage. And if you see in my local storage, I already have a token. I'm just going to go ahead and clear this out. So there's no token, and now if I refresh, you see there are no buttons visible over here. So now let's actually try to log in. I'm going to use one of these users that I have created on the server. It's called John Doe, and I'm going to use the password. That is very simple, 1 2 3 4 5 6 in our case. Now I'll click on login. Before that, let me open the network tab and let's look at the request that goes out. So before actually logging in, let's try an invalid password. This is an invalid password. I just added some more characters. Now if I click on login, you would see I'm getting the alert saying login failed. And if you look at the request as well, I'm getting 401 back. And you see the message invalid credentials. If you look at the server, you would see if the user details are invalid, then we return a response saying invalid credential. So it means everything's working. Now I'm going to actually log in with the right password. And as you can see, the request was successful. We got a 200 response and we got the token in the response as well. You could see the 3 buttons now being visible, and if you go to the application tab and if you look at the local storage, you'll see that the token is created and it's in our local storage. So now I'm going to copy this token, head over to jwt.io, and I'm actually going to paste this token here. Now as you can see, this is the data that is visible in my token. So if you see, we have an ID. This is the same ID of the user that we use, ID 1. We have the email and we have the username, which is all what we were using to generate the token right here. Now, as you can see, we're also looking at saved payments, right? Now, if you see in the token, I have the card number and the expiry for all the payments that have been saved. I'm just going to turn this off. Yep, better. So if you see, we have these saved payments in the token. Now, a very important thing about JWTs is that while you're not able to edit the token without invalidating the signature, but the data within the token is actually visible in plain text. So you can see that the data over here is visible. So what this tells us is that this is not a safe place for us to pass any sensitive information. So if you're trying to pass any sensitive data and if you find yourself using a JWT to do that, then you need to stop and you need to think about it again, because JWTs are available on the client side, and on the client side, if you are able to access the token and that token has data in plain text, then that sensitive data is not going to be sensitive anymore. It's going to be visible to anyone who is able to access the JWT. So this is the first thing that we want to avoid, that is to not pass any sensitive information in the token. I'm just going to go back into the code. I'm going to remove this line because we don't want to pass any sensitive information. I'm going to save it. I'm using NodeMon, so anytime I save it, it automatically runs the application again. Now we don't have a login feature here, so I'm just going to clear the token again, refresh my app, and then I'm going to try again. So John Doe 1 2 3 4 5 6. Let's try this again. We have a token. Let's copy this token, head over to jwt.io again, and if you see, there's no CA payments here, so I removed that and we are good. So ensure that you're not passing any sensitive information in your tokens at all, because this is highly unsecure. Now let's look at how these tokens are actually supposed to work. Usually a client makes a request to the server. This is a login API call and they get a JWT back. And as you saw, every time the client makes a request, they pass the token in the header, a authorization header, and the server validates the token, checks if the token exists as a bearer token in the auth header, verifies the signature of the token, it verifies the token validity, and then it accepts or rejects the token. If it accepts, it will continue with the processing for the rest of the API call. If it rejects, it is just going to throw an error and you'll see an error in your API call. Now, let's look at some of the things that we need to keep in mind to ensure that our tokens are not unsecure, they're very safe, and you can use them in a very secure manner. Number one is what we already saw. We need to ensure that no secrets are passed in the token. So we were passing the payments data in the token. We need to avoid this entirely. We cannot pass any secrets in the token. It has to be metadata about the user that will just help you manage the session. So using the email ID, etc. is something you can use on the front end. Although an ID is mostly going to be enough, you don't even need to pass the username and the email. And with just the ID, you can fetch all the data for the user from the backend. In this case, we are passing username and email, which is okay, but still, which is okay, but you don't want to pass any more data than required in your token. Certainly not any sensitive information. Now we saw this, that we are validating the token on the server, right? Now, how does this happen? So in Express, we use something called as an Auth middleware. Let's look at the middleware for now. We take the token from the header, the authorization header. We split it. So first of all, if that doesn't exist, we're going to throw an error 401. Then we split it. We get the second part of the token. In a bit, we'll see how this token is actually being passed and it will make more sense. Once we have the token, we check if the token actually exists. If not, we throw an error. If it exists, we're going to do some verification. We use the JSON Web Token package to verify if the token is actually created by this same server using the same private key that was used to generate the token as well. If you see, we use this private key which is coming from the same place to generate the token. So verification also requires the same private key. If I were to use an invalid key over here or something else, then this isn't going to work. So it has to be the same key. Then we're just taking the decoded, so this verify function will return the decoded version of the token. Decoded information within the token is this part. This is what it will return, and we are just setting it to the request.user object, so that every time in the request, if you want to access the user who is logged in, who is making this request, we can use the request.user object. That's it, really simple. And if there is an error, so if verify throws an error, it goes to the catch block and we're just returning 403 here. So for now, I'm going to comment this part out so we can see a few different things. Now, as you can see, we have 3 buttons here. Let's go back to the network tab. There are 3 buttons: call the API without token, call API with invalid token, and call with a valid token. If you look at the front end code, I'm getting the token as a variable, as a parameter. For the first call, I'm passing an empty string. Here, I'm passing an invalid token. It could be anything. It could be basically this thing, right? It doesn't have to be it's anything but a valid token. And here, I'm actually passing the valid token, which is coming from the local storage. In the function, we are making a call to this test API. We are not passing any body, but we are passing this header. And if you see, we are passing an authorization header, and this is how we are passing the data. This is a general common way to actually pass JWTs to the server. This is called a bearer token. So we use the word bearer space and the token itself. This is the reason in the auth header we are breaking the bearer token down, splitting it by a space and then taking the second part of it. This is the actual token. This is a very common convention that is used by most applications when it comes to JWTs. Alright, so now let's use this button to call the API without a token. So this one actually should have thrown an error. The reason it does not throw an error is if you see, the request received from undefined is the message that we see, whereas what we are expecting is to have the actual username of the user that is making the call, in this case John Doe. But the reason it does not work is because we're not using the auth header. So if I uncomment this out and we use the auth header, the auth middleware, then this error should go away. And this brings me to the third point, which is correctly validating tokens. Before that, we need to make sure, this is a very important point, that we need to use strong secret keys. We cannot use a secret key that is something that anyone can guess. For example, if I go to jwt.io and here if I enter my key, so this is my key, super secret private key. Now again, this is not a good example, this is just to give you an idea, but this should be something that is very complex, very long maybe, and this should be very private and very secretive. So no one really should have access to it. So if you see, if I enter this, it gives me the signature verified response. Now if I change something, obviously it's going to say invalid signature because the signature is not something I'm generating again. But basically what it tells you, if someone gets their hands on the secret key, then they can generate their own tokens, which can bypass your security systems, and an unauthorized user can actually access your system. We definitely want to avoid this. So these secrets have to be super secure. No one should have access to them. It should ideally be generated and it should be rotated, meaning every few days the token should be, the secret should be changed to a new value, and no one should have access to this, not even super admins. Not even your boss, or no one in your company, no one in your organization should have access to this token. This has to be a very secret value. Right, going back, that is the second point. And third point is we need to validate the tokens correctly. In our case, we were not passing the middleware. So if I start doing this, you will see in my middleware, I'm getting the token. If the token doesn't exist, I'm throwing an error. So this, we are always passing a token. But the second part of it, if we don't have the token after the bearer word, then it's also going to throw an error. This is what I expect to see now, because I'm calling with an empty string. So bearer space empty string is what we'll see. And let's look at the app. So now if I make this request, you see there's an error. This is the right error, no token provided. So let's look at the headers. If you look at the headers, you'll see that we are passing the authorization header and it's just bearer. There's no token after it. So this is why it's hitting this point where it's not able to find a token and it's returning a status code of 401 with this message. Now the next thing is we are going to pass an invalid token. Now again, this should fail with this 403 status code, but if commented this part out, so obviously it's going to work. Again, what we are seeing is the response is undefined because we are not actually verifying and decoding the token, but it's giving 200 regardless, even though we are making the call with an invalid token. To do this, we are simply going to uncomment this code out, so we understand that verification of the token is really important. We need to verify that the token is being created by the right private key, and once it is verified, it's also going to decode, and that's when it's going to be available within the user object in the request. Going to save it, it's automatically going to restart the server for me. Now if I make the second call, you'll see it fails. I get a 403 error and the response is invalid token, which is coming from right here. Finally, if I make this third API call, you'd see that we get the right response, request received from John Doe, and you'd see this is the part that it is hitting. So it's calling the next middleware and it's getting to this point where it's actually returning the response in the right manner. This is it. This is basically how you validate a token. This is generally how tokens are validated on the server side, and it's very simple. You just basically have to use some ready-made functions that are available for you, but you need to make sure that you do all the right verifications, you do all the right checks in the right places. Otherwise your tokens are going to be highly unsecure. Now, while getting the token, while validating the token, you could also do a lot more. Like you can use the token to actually look at the database, make sure that it's the right user, etc. But you don't want to do a lot of things either. Don't want to make a lot of database calls because you don't want to make your API too slow before it actually does the job it's supposed to do. So you don't want your middlewares to be super slow. You want them to just do the thing that is enough to make sure that the request is authenticated and coming from the right source. Another few tips is to enforce HTTPS. Right now, obviously we are on localhost, so we are using HTTP, but in your application, you want to ensure that the requests are always coming from a secure source. The request should only be over HTTPS, never HTTP. This will again add a layer of security so that there's no attacks to your server, and you'll ensure that the requests coming are from a secure source and never over HTTP. Finally, we want to make sure that the tokens are short-lived. What does that mean? So if you see in this token, there are two fields. There's one field called IAT. This is what it says issued at. This is the timestamp at which this token was issued at. Now there's no expiry over here because if you remember, we commented this part out. This is where you can actually set an expiry for your token. So I'm just going to try and set it to 1 or let's just set it to 10 seconds for now. And I'm going to open an incognito mode, go to localhost 3000. As you see, I don't have the messages right here. I don't have the buttons right here. I'm going to log in. I'm going to click login. As you can see, I have the token. I'm going to make this valid token request and you see I'm getting a valid response. Now let's look at the token that is generated. I'm going to copy this, head over to JWT.io again, and if you see this time we have an expiry as well, and if you see this expiry is actually 1554.01, which is again right now. If you see, this is 1553.51 is when the token was issued at and expires at 1554.01, which is exactly in 10 seconds. So now I think 10 seconds have passed, and if I make this request again, let's go back to the network tab. If I click on this again, you'll see that this time I'm getting an invalid token error, and this is because my token has expired because it has a very short expiry. Obviously you don't want it to be 10 seconds or even within minutes. Usually it's you can set it to an hour. Some banking applications set it to 15 minutes or so, but typically all other applications set it to like at least an hour or in some cases even a day. Some applications like meta applications, they probably don't even set an expiry, or maybe have a very long expiry that lasts for months. That's not really recommended if you want to have a very secure application. But you need to keep in mind that the shorter the expiry, the more often the user is going to have to log into the application again. So you need to find a balance that works for your application, find the right expiry time. But it could be any number, it could be in seconds, it could be in minutes, it could be in days, and even months. I'm just going to set it to 1 day, which is enough for my application, for this hypothetical application. That is it. These are the few simple principles that we have learned today to ensure that our tokens are safe and secure. We are using JWTs in the right way. Now, of course, there are ways to hijack these tokens, such as cross-site scripting and etc. But you need to make sure that your application is safe against cross-site scripting, etc. The excesses, attacks don't just affect your JWTs; it affects your entire application as a whole. But you need to take additional steps to make sure that your JWTs are much safer, so that there's no unauthorized access to your application resources, there's no unauthorized access to anything, and only the intended users are allowed to make requests to your server. That's it. This is how you secure your tokens. If you enjoyed this video, do like, share, and subscribe so that you keep getting such tech content on a regular basis. Thank you. Bye bye, and see you soon.